All right, good afternoon, everyone. I'm Alan Gerard. This is our Balanced Weather Live, and this is a bit of an experiment today, as this is the first time I've done one of these where I've tried to cover a variety of topics, just going from one thing to another, and I've got a lot of screens up here that I want to share some different graphics with folks, so we'll see how this goes. And once I post this, if you have any input or suggestions on things you'd like to see differently or better, please feel free to share. So we're going to start off today talking about, as you might expect, the Texas catastrophic flash flood event from a week ago today. And what I in the last couple of posts that I've made on balanced weather about this event, I've really by the way, I have dogs in the background, so you may hear a little shaking or barking every now and then. I've really focused over the last couple of posts on the warnings, and the reason for that, from my perspective, as somebody who worked for the Weather Service for a long time and has been in this business, both from a meteorology perspective and an emergency management perspective, the warning is really kind of the true safety net. We can have events like this where there is very little forecast or warning, or excuse me, very little forecast or outlook leading into the event. So we really, from an emergency response and preparedness perspective, really put a lot of emphasis on the warning and people being able to receive and act on the warning. But having said that, I don't want to diminish the importance of the outlook and forecast and, the information that's being provided to the public and some of these key decision makers like emergency managers leading up to an event. And I actually had a good conversation last night with one of my former Weather Service colleagues talking about this, and it kind of reinforced in my mind that I do want to emphasize that the outlook and forecast is important. It's just, to me, it's not, the fact that warnings were out and in effect and the warnings were done well is the most important thing. But we don't want to diminish the input of, or the importance of the outlooks, the watches leading into an event. And so one of the things I wanted to spend a little time talking about today is, there's been some discussion about the rainfall forecast leading into the event, and that it probably wasn't really high enough. And I mentioned in the article I did last night about how there's been some reporting about sorry, the dog is, give me 1 second. I'll shut this out. Shut the blind so he can't see. So the there's been a lot of coverage about the rainfall forecast leading into the event, and the fact that it was a bit underdone, and that some of the modeling as we got closer to the event was increasing the rainfall. And the article in the Washington Post about this event really focused on looking at some of the the various high resolution models that we have to forecast these types of event. And I wanted to kind of focus on some of the probabilistic aspects and the fact and the ensembles, and for to give you some perspective on what exactly an ensemble forecast is. Essentially, we have these computer models that we get all of these parameters from, like rainfall forecasts that meteorologists use to make their forecasts and outlooks and decide to issue watches and things like that. An ensemble forecast is basically where you take the various models and you tweak the initial conditions that start the modeling process off, so that you get these a number of slightly perturbed solutions that give you an idea. We know that there's error in any computer model forecast, and basically what we're trying to do is get an idea of the more likely alternative scenarios to the ones that we're seeing on the main models, and that gives us some idea of the uncertainty in the forecast, and also gives us some alternative but realistic solutions that we can look at. And one of the Ensemble forecasts that we can look at is the high resolution Ensemble forecast system, and that's what I have up here. And this is the actual forecast from this model that was made on the morning of July 3rd. So this would have been the rainfall forecast from this model, a 24-hour forecast ending at 7 p.m. Central Time on the evening of the 4th. So basically, this is the 24-hour rainfall forecast covering the period from 7 p.m. on the night of the 3rd to 7 p.m. on the night of the 4th. And what we're trying to do with these Ensemble forecasts is, as I said, is kind of try to see what some of the kind of worst case scenarios are. And in this particular situation, I apologize for the dog. He's been quiet all day, and now he's decided it's time to have all sorts of issues. So what we're really trying to do is anticipate what some of the the worst case scenarios are. And what we can see here, if we look, this hopefully you can see my cursor here, but we're looking at San Antonio here on the map, and some of the heavier rainfall totals here are to the northwest in the general area of Kerr County, where the where the flash flood tragedy occurred. And you can see here that this particular model is showing some rainfall amounts of, if we look at the chart down here, is showing some amounts of 5 to 7 with even some localized amounts of 10 inches. And what we're looking at here is a technique called the localized probability matched mean, which basically means that a lot of the Ensemble forecasts we look at, it's just taking the mean is where it takes all of these various perturbations that are generated by the model and just averages them out. This is a technique that we utilize to try to keep some of the maxima that some of the models are forecasting. We try to preserve those so they're not just all smeared out in some of the means. In other words, we're trying to be able to see where some of these localized heavier totals might occur and how high they might be. And you can see here that the model is showing some, as I said, some localized maxima of as much as 10 inches in the area around Kerrville. So clearly there were some signals in the modeling that showed that some of these locally really intense rainfall forecast or rainfall amounts could occur. But what's important to recognize is that there's no way to know exactly where those maxima are going to occur. And for a flash flood, you really have to know the exact locations where these amounts are going to occur in order to be able to, adequately show what kind of response there's going to be on some of the streams and really be able to anticipate the magnitude of flooding. So, one of the things that I was involved in when I was working at the National Severe Storms Lab was this project called Forecasting a Continuum of Environmental Threats, or FACETS. And what FACETS is really all about is the idea that we're trying to develop some of these probabilistic approaches that will enable decision makers like emergency managers and people that own campgrounds in flood-prone areas to be able to better be aware of the threats that are potentially going to impact them, and also be able to kind of anticipate some of these low probability events, but that if they occurred would be really high impact. And even though we couldn't anticipate that 7 to 10 inches of rainfall was going to fall right on that exact spot where it would produce the extreme flash flood that we actually saw there on the South Fork of the Guadalupe River. One of the things that we're trying to look at, both from a physical science perspective and a social science perspective, is whether or not we can potentially come up with visualizations that would enable an end user to very quickly be able to look at it and see, okay, this is a situation where I really need to think about taking some preventative action. And I just kind of wanted to show here, as part of this conversation, go back and look at the actual river gauge from the Guadalupe River at Hunt from the night of the event. And you can see here, the river rose, literally rose 30 feet in a period of just a couple of hours. And this is the kind of rapid flash, this is just a classic flash flood response. And one of the things that's been going through my mind as I've been thinking about some of this probabilistic stuff is whether or not there's a way to, show an end user like an emergency manager the probability of this type of a rapid rise occurring, so that they can actually envision. I just think that there's more of a human impact when you see a graph like this, rather than somebody tells you, there's a 10% probability that you're going to get 8 inches of rain tonight. There's just not a lot of impact with that. So another thing that's really an important part of this whole idea of, utilizing probabilistic information to give decision support to these end users that they can potentially utilize to make decisions to keep people from being in a risk area like this, is the importance of people who can interpret the information for them. That's why the Weather Service is looking so closely at this idea of, having people in local offices who can provide decision support to people like emergency managers, because it takes some experience with all of this data to be able to really kind of explain to an end user what the potential impact is, and what the probability is that this kind of a rise is going to occur on a river, and really engender the kind of preventative action that we want to see people take. So I just wanted to talk through some of this, and kind of just to kind of reinforce that that I didn't want to minimize the importance of some of these outlooks and decision support information leading up to an event. But I also, I think if people get overly focused on this, they can lose sight of the fact that good warnings were issued during the event, and obviously a number of people did take proper preventative action. So we really do want to, I think, take a close look at where the gaps were during this event, and really try to learn from it, and hopefully, do things to be able to prevent these kind of tragedies from happening going forward. So that covers what I wanted to talk about with regard to that. The other thing I wanted to focus on was spend a little more time having um, a bit of an opportunity to do more discussion on some of the news that's going on with NOAA and the National Weather Service and some of the budget and staffing issues. So I just saw this afternoon an article from the Union of Concerned Scientists about Dr. Neil Jacobs' confirmation hearing earlier this week on, let's see, today's Friday, so I guess it was Wednesday. The NOAA, or excuse me, the Senate Commerce Committee did a had their confirmation hearing for Neil Jacobs, who is President Trump's nominee for the to be the administrator of NOAA, essentially to be the senior scientist in charge of the National Oceanic and Atmospheric Administration. And this article is interesting in that it really raises a lot of concerns about that. I watched most of the confirmation hearing, and I thought that some of the points that the UCS brought up were interesting. For those of you that aren't aware, Dr. Jacobs was in NOAA leadership, was a NOAA political appointee during President Trump's first administration. And he was involved in the what has come to be known as the Sharpiegate scandal, where President Trump essentially said that, you know, on social media that Alabama was in risk from this hurricane when they were not at risk. And then the next day, when President Trump was involved in a press briefing regarding the hurricane, he had went in and actually drawn on the NOAA forecast to make it look like Alabama was included in the threat area. And this led to a lot of political fallout and a lot of internal NOAA, I don't know if concern is the right word, but a lot of internal strife within NOAA. And Dr. Jacobs bore a lot of the brunt of that from all sides, to be honest. And, you know, some of it, I think, you know, obviously, I mean, he admitted himself that he wished that some of what transpired had been handled differently by himself and other members of NOAA leadership. But regardless of all of that, as we've come around, he is once again the nominee. And the Union of Concerned Scientists, their top line concern about Dr. Jacobs' nomination and what went on in the confirmation hearing on Wednesday was that he basically said that he supports the president's budget, which, as I've discussed extensively on Balanced Weather, would result in a 27% cut to NOAA and the elimination of the Office of Oceanic and Atmospheric Research, and obviously a number of significant impacts to NOAA. As somebody who was a federal scientist for 35 years and was in NOAA leadership for the last 2 decades of my career, I'll just say I've become very realistic about a lot of these political situations, and I didn't expect Dr. Jacobs to say anything any differently during this confirmation hearing, because the reality of it is he is interviewing to become a member of the administration, and he's not going to go in front of Congress and say that he opposes the presidential budget. That would pretty much be the end of his nomination. I felt like he did say some encouraging things about the National Weather Service staffing, and at least acknowledged the role of humans in climate change, even though it was, as this article notes here, a bit of a wishy-washy answer where he emphasized also natural signals, but he did acknowledge the role of human climate change. And he did also talk about a number of positive things, like the importance of social science. He talked about the potential for having some sort of a national disaster review board that would go in and do independent reviews after events like the Texas flash flood disaster, and hopefully make independent reviews similar to the National Transportation Safety Board. So, in my take on it was that it was rather, it was mixed. It was, I would have hoped to have heard more positive comments about OAR and the NOAA budget, but realistically, it was really kind of about what I expected. As I said, as time has gone on, I've become rather a realist about this stuff. And just to be frank, what concerns me is if Dr. Jacobs wasn't the nominee, is what would the alternative be? And I think a lot of the alternatives that could be promoted by the Trump administration would be a lot worse than Dr. Jacobs. Dr. Jacobs is a meteorologist. He does have, a lot of experience working with and for NOAA. And, when he was the deputy administrator during the first administration, he did make a lot of positive, he had a lot of positive influence on the organization. So obviously this second administration is very different than the first administration. The attacks on science and the budget of the science agencies has been much more aggressive and much more effective than the first go around. And I think we have every reason to be very concerned about the direction that things are going. But having said all that, I also think there's reason to be concerned about the potential for where, I do think that with all of the concerns that this UCS article outlines, I do think that Dr. Jacobs has some positive ideas and directions he'd like to take the agency. So as with everything, there's a lot, it's complex, there's pros and cons, but it will be interesting to see how this plays out in the coming weeks. With regard to the budget specifically, as I mentioned in this morning's newsletter, the Senate Appropriations Committee had their markup hearing on the budget yesterday. It seemed to be positive for science overall, but we don't know the specifics because the bill was tabled because of disputes about the potential relocation of the FBI headquarters building. So, we don't really know the details, but, as I alluded to here in talking about Dr. Jacobs' nomination, the administration has outlined what it wants to do with NOAA. And what it wants to do with NOAA is eliminate the Office of Oceanic and Atmospheric Research and push forward pretty aggressively with eliminating most of the research capacity that NOAA has, both with the federal scientists and the associated university cooperative institutes, and also eliminating things like NOAA Sea Grant and the regional climate centers and pretty much all of the climate funding. While what we saw yesterday with the Senate seeming to push back a little bit on some of these presidential proposed cuts is positive. It's more positive than if they would have just accepted them. The Senate operates in their appropriations process is done in a very bipartisan approach, and the reality is the House is much more tends to be more partisan, and the initial signals are that they're going to align more with the president's budget. So it's likely that it will not be as positive as the Senate. And the other thing is, as we saw today, and I was just reading some of the articles in preparation for today for this video, now that the Supreme Court has ruled that that the administration can move forward with their agency organization plans broadly across the government, they're starting to push forward, like with the State Department, with a significant downsizing of the State Department. So I think there's still serious reasons to be concerned about the direction that the administration is looking to take NOAA. And, we need to continue to, be diligent. Now, having said that, I do think that there have been some positive comments made in the aftermath of the tragedy in Texas. And if nothing else, within the nomination hearings of Dr. Jacobs, and there were also two other NOAA political appointees that were being discussed at that nomination hearing. There were some comments about the need to keep some of the OAR research that's being done for weather, but move it into the National Weather Service. Now, obviously, I've written about this on some of the balanced weather stuff, that I have concerns about having the research within the operational agency, because I think that leads to a situation where it's very easy, as the operational budget comes under strain, to cut back on research, and that's been something we've been able to avoid by having a separate research office within NOAA, as the Office of Oceanic and Atmospheric Research is. But obviously, we ultimately want research to be able to continue to be done. So hopefully there are conversations going on with the administration and some of the key appropriations figures, like Congressman Tom Cole, who is the head of the House Appropriations Committee and also happens to be the congressman that represents Norman, which is where I'm at and where the National Severe Storms Laboratory is based, and where the University of Oklahoma, which is a major part of NOAA's research organization, is based. So it will be interesting to see in the coming weeks what kind of just behind the scenes things we start to hear about some of the conversations that might be going on as far as potentially protecting some of the weather and flooding research in the wake of what we've seen in the last week with the tragedies in Texas. So those are the two main topics I wanted to cover in today's video. I don't see any questions in either the main chat or on here. So let's see. A question from Roberta: were there timetable exercise among the responders? That's a really interesting question, and I can talk a little bit about that. And if anybody else has any other questions, please feel free to put them in. This is one of the things that that hopefully we'll learn more about in coming weeks. I mean, just to be pretty direct, what we've learned so far in the week since the flood disaster in Kerr County is not particularly encouraging from my perspective as somebody who's been very involved in weather forecasting, weather warning, emergency management over the last, over my 30 plus year career. It just does not seem like the type of emergency preparedness activities and procedures and regulations were in place that you would expect given the tremendous vulnerability that this area had. It would be one thing, I was actually talking with my wife about this a couple of days ago. It would be one thing if this flood tragedy had happened in an area that had never experienced a flooding event like this, where it was very much a surprise. That's not the case here. This area is a known vulnerable area. There's been obviously a lot of conversation about whether or not there should have been more warning systems in the area. And all of those kind of discussions are fine to have. But what I really want to know is, were some of what would be considered basic emergency management actions taken, like your question, Roberta? Were there tabletop exercises, done to try to, gameplay out a flood event like this, and how county and city resources would respond to an event like this? It would seem to me like, given the number of people that were in a vulnerable location, and particularly the fact that routinely, you had large numbers of children in these vulnerable areas, that it would have just been very, just kind of standard operating procedure for county and state emergency management to have been aware of the vulnerability here and had aggressive training and planning for it. As of now, that doesn't seem to be the case. I would assume that we would have heard by now if there had been, 5 years ago, some big tabletop exercise among emergency managers and responders to prepare for an event like this. And certainly what we've seen reported as far as the warning receipt and dissemination in the county doesn't seem to have spoken of a really strong emergency plan. Now, having said all that, that's not to let individuals and the individual campgrounds off the hook either. They obviously everybody bears some level of responsibility here. And as I've said multiple times, it shouldn't be about pointing fingers. It should be about trying to figure out, the event has happened now and the tragedy has happened. What we need to do is learn where the shortfalls were, and number one, for this area, to make sure that we do everything in our power to keep it from happening again, but then also to learn for other vulnerable areas like this, so that we don't have this tragedy somewhere else. So did anybody else have any questions about the Texas event, about budgets, about anything? You can put it in the chat, or you can hop off of mute and ask. All right. Well, if there are no other questions,
I'm not going to let you off that easy.
I was
Um,
hoping not. I was hoping somebody. I was hoping somebody would grill me.
okay. Do you think that there was any impacts of the Weather Service messaging regarding the risk, given that they were out of sync with the local news cycle? I mean, back in the days when I was involved with offices, there was an emphasis put on trying to get good messaging to sync up with the local news cycle, especially if there was something large and impactful coming up.
Yeah, I guess the easiest way I would answer that is I think that that's of everything that I've seen as far as what the local office did with this event, what transpired the evening of the event and the evening prior to the event. In other words, the evening of July 3rd, before the rain started, but as some of these high, later arriving higher resolution models were suggesting even heavier rainfall amounts, and the Weather Prediction Center had issued a mesoscale discussion talking about increasing flash flood risk overnight. I think probably the place where if I were the meteorologist in charge here and I was doing a post analysis of this event, that's probably the area I would be focused on the most. Was there some messaging there that would have that could have taken place that would have helped even raise awareness more than just the flood watch had? And I think that's a very reasonable question, and I hope that's an area that will be looked at. And going to what you're saying, Ken, it was always a thing when I was still in the Weather Service. Like if we were going to have an overnight tornado event, that we would try to get the tornado watch out before the 10 p.m. news, so that before people went to bed, they could see that there was a tornado watch in effect and be aware accordingly. Um, that's the kind of you know and to be fair, one of the things we don't know is what might have been being said. And like, NWS chat is now a big way in which um, uh, the Weather Service provides information to emergency managers and broadcast meteorologists. And it's certainly possible that there was discussion going on in there about the increasing risk, but that would definitely be an area I would be looking at to try to see if there was more that could have been done. Having said all that, there was a flood watch in effect, and the thing that really stands out to me is this was a known very vulnerable area, and it just seems like the amount of awareness of the vulnerability that this area had seems to have varied among all of the different people and campgrounds and resorts that were in the area. Some seem to be taking it very seriously. We're monitoring weather radio through the night. Took pretty quick protective action. Others seem much less aware. So I think there will be a lot of social science done in the coming months to try to understand what people's awareness level of the vulnerability was, just the base vulnerability, what the awareness level was of the particular risk that night, and what we can do going forward to try to improve all of that.
And thanks, Alan, for that background. I see many parallels of this event to the Big Thompson event in Colorado, the Rapid City flash floods. A lot of interesting parallels. The first figure you showed of the model, could you bring that back up?
Yep. Just a sec. Whoops. There you go.
Yeah. What I find interesting going back and looking at the model results, especially when you compare it to what was going on in real time further north, where you have the secondary maximum further north of the one, that the models had caught on pretty quickly to what was going on in real time. In other words, even before the first drop fell with the flash flood, there were 2 or 3 inch rainfalls occurring with accumulations up to 7 inches a couple of 100 miles away from where the main flash flood took place. And the models, like in this case here, clearly locked on that the atmosphere was going to be very conducive to very heavy rainfall amounts and potentially catastrophic flooding.
Yeah, and something I'll just add, Ken, and I didn't get into this, but I had it up, was if you look, whoops. If you look at the the later run, the evening run of the same model, so in other words, this was the run that was done 12 hours later, you can see how even heavier the amounts get. Now, obviously, the Weather Service did not have access to this until the flood was already, until the heavy rains were already in progress. So this really wasn't necessarily available for the flood, for the flood outlooks or the forecast. But it just does show that as we got closer and closer to the event, and kind of as you're saying, the models picked up on it. And I have not seen the results from this, but my understanding is that the Weather Service and NSSL have went back and rerun the Warn on Forecast system, which is the experimental, really high resolution runs that are high and that are run every 30 minutes during events to try to help forecasters be able to better anticipate these severe weather and flash flood hazards. And from what I understand, as you got closer to the event, the model did increasingly well, but really didn't, capture the full impact, the full potential impact and location until, again, just about as the rains were starting to develop. But it does give some hope that between modeling and observational approaches, we can continue to increase the lead time on these events. Because really, obviously, what we really want to get to is the point where we have good enough modeling that we can say with confidence that, with enough confidence that an event like this can happen, that people will take proactive action well before the event. All right. Any other last questions? All right, well, I am going to stop the recording, hopefully.